So we have 3 airports that each start out with 9 planes. And then every day, 2 planes depart from one of the airports, and then each one airport goes to the other two. Demonstrate what that means later. And then, so no other planes depart from or land at these 3 airports. So one evening, when no planes are flying, Nate notices that there are 3 planes at one of the airports. And then he takes the number of planes at the other 2 airports and multiplies them. And then we want to know which of the following numbers could Nate have written down. Okay, so the first thing that we want to do for a lot of these questions is to just like play around with it and see what's going on. So let's say we have 3 airports. We have let's just number them 1, 2, and 3. And the question says each airport starts out with 9 planes. So we have 9, 9, and 9. This is our first day. So let's just say, for example, we randomly choose airport 2, right? So 2 airplanes, so it's minus 2 planes. Now we have 7 planes. And then 1 plane goes to airport 1, and then 1 plane goes to airport 3. So now we're gonna have 10 planes here and 10 planes here. So let's just say another random plane. Another airport. So let's just say airport 1. So the next day, 2 planes depart from airport 1, and 1 goes to 2, and 1 goes to 3. So airport 1 will have 8 planes, and airport 2 will have 8 planes as well. And then airport 3 will have 11 planes. And then let's say 2 planes depart from airport 1 again. So then we'll have minus 2 planes here. We'll have 6. We'll have 9 planes in airport 2. And then we will have 12 planes in airport 3. Okay. So we want to get to a point where there's only 3 planes at one of these airports. But we don't really know how we get there, right? This process could take like 5 days, 10 days, like a whole year, and we wouldn't know. So with all of these like variables and differences going on, we want to find something that stays the same. And you don't have to know this, but in mathematics, we call this an invariant, which is something that stays the same no matter how many times or how many days pass. So let me just introduce what the invariant is. It's very hard to see initially. So we're going to actually divide every number or the number of planes by 3 and look at the remainder. So for the first day, 9 divided by 3 is 3 with a remainder of 0. Let's just go remainders here. So we have 0, 0, and 0 as our remainders, 1 divisible by 3, 1 divided by 3. And then for the second day, 10 divided by 3 is 3 with a remainder of 1. 7 divided by 3 is 2 with a remainder of 1. And also a remainder of 1 for our last airport. And if we calculate this for the next day, we'll see it's 2, 2, 2. And then the next day we go back to 0, 0, 0. So we see something very interesting here. We see that no matter what day it is, all 3 airports have the same exact number when divided by 3, the same exact remainder when divided by 3. And one way we can show this is after every day, 2 of the airports will increase the airplane amount by 1, and then one of them will decrease by 2, right? So from this day to this day, airports 1 and 3 increased by 1, and airport 2 decreased by 2. So if we increase the number by 1, the remainder will also increase by 1. So it'll go from 0 to 1, 1 to 2, and then 2 to 0. However, if we decrease the number by 2, we're also increasing the remainder by 1. You can try and convince yourself why this is true. So I claim like if we have like a number 7 that has a remainder of 1, and if we subtract 2 from it, we get 5, and then the remainder increases by 1. It goes to 2. So try and like figure out why this is true. I think it's a very interesting fact. Okay, so now let's get back to the question. We know that so after like a certain number of days, we don't know how many days, like after a certain number of days, one of the airports have 3 planes in it. Okay, so one of the airports has 3 planes, and then we don't know about the other 2. It has one of them has X planes, and the other one has Y planes. We don't know what the numbers are yet. However, we know that the remainders of the first airport is 0. And based on this invariant, or like the fact that we showed all the airports have the same remainder, we know that airport 2 and airport 3 also have a remainder of 0 when divided by 3. So that means both X and Y are divisible by 3. Okay? And this means that if we take the product, we want to find the product, remember? So we have X times Y. Notice that this is going to be divisible by 9. Since x and y are both divisible by 3. So if we look through our answer choices, we actually see that A is the only answer choice that we can divide by 9. So B actually is not divisible by 9, C is not either, D is not either, and E is not either. And a quick way, once again, a quick way to check if a number is divisible by 9 is you can just add up all the digits and see if it's divisible by 9. So if you add up all the digits of B, you get 1 plus 4 plus 0, which is 5. That's not divisible by 9. Same thing, 1 plus 2 plus 8, you get 11, which is not. But if you do it for A, you add the digits and you get 9, which is divisible by 9. So since we know that the product must be divisible by 9, the answer has to be A. And this is actually constructed when x is equal to 6 and then y is equal to 18. And see if you can like have a configuration of days to make the 3 airports be 3, 6, and 18. See if you can figure out how to make the airplanes fly throughout the airports. And yeah, this is a really hard question, but I think it's very cool and very interesting. And there's a lot to learn. So thank you.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.